The annual percentage yield, or the APY of an investment, sometimes called the effective rate, is the percentage of profit that the investment generates in a one-year period. The APY considers the value of the investment when both the APR and the frequency of compounding are taken into account. When comparing investments with different APRs and different compounding frequencies, the APY is the right tool to use. We are going to be comparing 3 different investments by using the APY. The first of the 3 is looking at something that has an APR of 6.7% compounded continuously. The next one is APR of 6.75% compounded monthly, or an APR of 6.8% compounded quarterly. We know that if all the APRs are the same, that if it was compounded continuously, the interest was compounded all the time, that would achieve us the highest future value. And the compounded formula that would be compounded the least, like compounded quarterly, where it's only compounded 4 times a year, if the APRs were the same and the principals were same, that would achieve us the lowest amount. But this makes it interesting because we have the best formula, compounded continuously, at the lowest APR, and we have the worst formula, the compounded quarterly, at the highest APR. And compounded monthly, which is in between, has the APR that's in between. So when we look at this information, how do we know what the best deal is? Now this really reminds me back to the first problem we talked about when we were talking about the quiz and the midterm and the final, where we were dealing with fractions that had a different denominator, and it was very unclear to see which was the best score on the test. But what we did is we took those fractions and we converted them into percentages, and the answer was very clear. Which answer was which quiz, midterm, or final was the best score. And so that's really what the APY is. When you're dealing with different values of n and different rates, the APY is the common yardstick that tells you exactly what is the best deal. So we're going to go ahead and do that with these 3 different examples. We're going to figure out which one is the best investment. So to keep things simple, yet still compare the APYs, we're just going to make the principal $1. It's going to be $1 for each 3 of these investments, and the time that we are going to vest it is just for 1 year. So to compare these investments, we will compute their APYs. So the first one is compounded continuously. So we're going to use the compounded continuously formula. F equals P multiplied by E raised to the rate times T. P is equal to $1. The rate in the form of a decimal is 0.067, and the time is 1 year. So we're just going to input these values into the formula, and we get F is equal to 1 multiplied by E at the rate 0.067. That is multiplied by the time of 1. And let's simplify this. 1 multiplied, this is going to end up being a number. 1 multiplied by this number is just going to be this number. So this 1 is really unnecessary. So I'm going to write E. I'm going to simplify this. E raised to the 0.067 times 1 is just 0.067. So that's what I'm going to write, 0.067. And then we just need to figure out, well, what is E raised to the 0.67 power? And so I'm going to use my calculator and find the E. The E, remember, is found under this second ln, and then just put in 0.067, close the parenthesis, and hit enter. And we get 1.069295478. Now what we need to do is, this is very similar to the percent increases. This is the whole, it's increased by this amount. This is our APY. So what we need to do is we need to take away that 1, that whole. And what we're left with is our APY in the form of a decimal. So the next thing that we will need to do is just take that decimal and convert it to a percentage. Move it over this decimal 2 places to the right, and we get our APY. Our APY is going to be 6.9, and I'm just going to round it 6.929. That 5 would round that 9, which would round that 2 up to 3. So it's going to be 6.93%. That's what the APY is going to be for compounded continuously, investment A. Let's go ahead and take a look at investment B, compounded monthly. Since it's compounded monthly, we are going to be using the general compounding formula, F equals P multiplied by the quantity 1 plus R divided by N, all raised to the N times P power, T power. P is $1. The rate is 6.75 in the form of a decimal, which is 0.0675. The time is 1, T equals 1. And since it's compounded monthly, that means N equals 12. So we're just going to go ahead and input these values into the formula, and we get F equals 1 multiplied by the quantity 1 plus the rate, which is 0.0675 divided by 12, all raised to the N. N is 12. 12 times T, which is 1. So we're just going to simplify this. It's an order of operations problem. F equals 1 times this number. That 1 is not needed, so I'm just going to write the parenthesis 1 plus order of operations. We have to do parentheses. We have to do the division with inside the parentheses, which would be 0.0675 divided by 12. And that actually ends up being 0.005625 raised to the 12 times 1 is 12. And I'm just going to simplify this. The next thing we have to do is just go 1 plus all that, which is equal to 1.0052625 raised to the 12th power. Now, when we raise this to the 12th power, what we end up getting is 1.069627937. So this is where our this is our whole. This is like a percent increase. Our APY is here. So what we need to do is we need to subtract the 1 away from it, and what we end up with is F equals 0.069627937. We convert this to a decimal, move it 2 places to the right, and we get our APY equals 6.96, and I'm just going to round it to this. The 7's going to round that 2 up to a 3%. So looking just at these two investments, this first one has an APR of 6.93. The second one has an APR of 6.963. So it's obvious when we compare these two percentages that this compounded monthly, 6.75 APR compounded monthly, is actually a better investment than 6.7 compounded continuously, even though compounded continuously formula is a better formula. This is the better deal so far. So let's figure out the compounded quarterly, C. So compounded quarterly means 6.8% APR compounded quarterly. That compounded quarterly means we're going to be using the general compounding formula, which is listed here. We're going to define our variables. P equals $1. The rate is 6.8% in the form of a decimal. We have T equaling $1 and N equaling $4. We're just going to input our values into our formula, and what we get is F is equal to P is $1 multiplied by the quantity 1 plus the rate is 0.068 divided by N, which is 4, all raised to the N, which is 4 times T, which is 1. Just going to simplify this. F equals 1 multiplied by this number is just going to be this number. This 1 is unneeded, so I'm not going to write this 1. I'm just going to start with the parenthesis. 1 plus, parentheses, we have exponents. We need to do the order of operations, which states we have to do the parentheses first. We have addition and division. Order of operations says we need to do the division first within the parentheses. So 0.068 divided by 4 actually ends up being 0.017. I'm just going to simplify this exponent. 4 times 1 is just 4. And then I'm going to do this, just going to continue on with the simplification process following the order of operations. We have to do parentheses, therefore I have to do the addition with inside the parentheses. 1 plus 0.017 ends up being just 1.017 raised to the 4th power. Now, when I put that into my calculator, I just put 1.017, use the caret, raised to the 4th power, hit enter, and I get a big old long number. 1.069753736. This is like the percent increase. There's the whole and the APY there in the form of a decimal, so I need to subtract 1, subtract the whole. I'm left with 0.069753736. I change this to a decimal, this decimal to a percentage, and my APY ends up being 6.975%. So if we're comparing the APYs of all 3 investments, it's easy to see that the compounded quarterly, the formula that would be the least desirable out of the 3, even though when it has the highest APR, it actually ends up having the best APY. So therefore, this would be the best investment. Investment C, investing your money at an APR of 6.8% compounded quarterly.